This
Thank
conference will
you.
now be recorded.
Thank you all. Welcome again in our morning talk. Today we have Dr. Azizul Azizan. We'll be talking on the topic IoT principles and ongoing evolution. And as usual, we appreciate everyone to off the microphone and camera for better performance. And if you have any questions, you may ask after the talk or you can type at the chat room. So with that, Doctor, I pass it to you.
Okay, thank you. Assalamualaikum warahmatullahi taala wabarakatuh. Alhamdulillah, I've been given the opportunity to. Okay, sorry, there's a background sound. Is my mic clear?
Appreciate all to off the microphone except Dr. Azizul, please.
Buat macam ada voice coming back. Okay, now okay. Thank you. Okay, okay, I think it's all okay. Okay, so alhamdulillah, for anyone who doesn't know me or remember me, I was at MCMC for 6 years. I was with Spectrum Simon, and then numbering, and then MCMC Academy. So MCMC is quite close to my heart. Okay, quite miss the environment. Okay, however thing changes, and here I'm now in the university. Okay, so when I started to look into what I'm going to be talking about today, I want to actually expose you all today to what is currently happening in the world of Internet of Things. Okay, so let me share my slides first. Okay, so my talk will be basically separated into two parts. The first thing is actually a brief overview of what is the Internet of Things. Okay, so maybe you have already understood what is Internet of Things, or not, maybe not all of you. However, I just want to have a quick review, okay, on a few basic things of what is Internet of Things. A lot of people have talked about this already, and maybe what I want to emphasize is only strengthening the main points or the main principles, okay? And in my second part of my presentation today, I will brief some areas of evolution, okay? Like technology will always evolve to solve new dilemmas or new problems, okay? Because technology will not be stagnant, okay? That's the nature of technology. So even though you have already Internet of Things maturing, there is a lot of
Data. Gila ni. Punya laptop baru ni.
All right, okay, thank you. Okay, even though there's a lot of thing that has matured in the Internet of Things, okay, the changes will always occur, okay? Changes will occur, new things will appear. Okay, so these are a few quotes from technology leaders. Okay, first is Bill Gates. Okay, like in 1977, he mentioned that every desk and home or even office will have a computer. Okay, so and then the second quote is what we call ubiquitous computing. So ubiquitous computing here means everybody, okay, or everything will have computing power. Okay, so this is mentioned by Alan Kay. Okay, and we have another guy called Mark Weiser. Okay, was one of the brilliant guy in Xerox. So he mentioned that the most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they're indistinguishable. So sebenarnya kan komputer ni tanpa kita sedar, dia dah masuk dalam hidup kita. It is already in the fabric of our everyday life. Okay, similar to communication. Okay, so we cannot live without it. I don't know anybody who can live without a mobile phone. Okay, so a mobile phone is also a computer. So in the computer, you have what you call, of course, the internet. So initially, kita manusia, we are humans, we are the users of internet. And why you have the Internet of Things is the users of internet is now also things. Benda-benda juga menggunakan internet. Okay, so itulah asal term Internet of Things. Okay, so this is the first part of my introduction. Okay, next slide. Okay, so when we look into Internet of Things, we cannot run away from what we call industrial revolution. Okay, so if you see this picture, okay, starting from top left, going right down, you can see the different phases of example. Okay, first is mechanization, ni zaman in the 1800s, and then you have factories. Okay, mass production, and then electrification. Okay, and then next you have what called computers and automation, where robots starts to come inside factory. Okay, so what happened, humans working with robots to do things, and finally in the final industrial 4.0 revolution, the human doesn't need to interact anymore with the robot. The robots can learn and the robots can adapt to the environment itself. Okay, for example, we have the last picture here. Okay, so all of this is enabled by actually computing and communication. Okay, this is one of the most important factors. Okay, where computers and communication are involved. Okay. Yes. Okay. You have what you call here. Okay. So next slide. Okay. One of the main reason is because computing power is now everywhere, and another important factor is because when you want to produce the computer nowadays, it is getting smaller and smaller. Computers are getting smaller and smaller. So I'm not sure whether you can see my camera or not. Okay. So I have a credit card here. Can you see? So this is a credit card, right? My credit card. So you can see in this graph, the computers are getting smaller and smaller. Okay, so even that the sensors are getting smaller and smaller. So with this advent of manufacturing of devices or computers, you can have computers in small sizes. Okay, so this is my credit card, if you can see. Okay, and this is what we call a Raspberry Pi. Okay, yeah, this is Raspberry Pi 4. This is actually a full-blown computer. board. Okay, so if you want to see the size, it is actually size of a credit card. Okay, so this is a computer already. So you just connect with the keyboard, a monitor, a mouse, and then yeah, you have a PC. Okay, and usually people power this Raspberry Pi board using Linux. Okay, Linux OS. Okay, so it's just a small box. Okay, so next, I want to go what is basically IoT. Yeah. Okay. How do you define what is IoT? Okay. So this is my definition. Okay. So IoT makes things smarter by using data, and after you use your data, after data is acquired, how to use your data is you have insights. Okay, insights to your business or your personal uh, applications. Okay, so how it is being done by embedding computing, communication, and applications. Okay, so computing is all in the hardware, communication is also in the hardware, and how do humans how will say process, okay, or interact, it's through the application, okay, or the software, the user software. Okay, so IoT is a network of dedicated physical objects. Okay, so when you talk about IoT, it is not necessarily things. People are also in the IoT. Okay, you have all like your wearables. Okay, and the most important thing is it must contain embedded technology to sense, interact with the internal or the external state, okay, of an environment. Okay, so I just want to give you a simple example of a key, a doorknob. Okay, so you want to open your door, you use a key. Okay, so if you go to hotels, they will use RFID card. Okay, so you have the RFID card here. Okay, so or you can use a uh, passcode. Yeah. Okay, and in the future, all the keys will be in your mobile device. Okay, so this is the door knob. So this will enable you to be connected to the door everywhere, every time, and of course to the thing. Okay, so this is just a very simple illustration of your door becoming a very smart item. Okay, but it is also, when it is smart, also when you enable it to be digitized, there's always issues of data privacy, and also the security of the door. Okay, maybe somebody can hack the door, somebody can open your house door. Okay, so the technology, the easiness of everywhere, every time, and everything, which is ubiquitous, comes with the issue of security and also privacy. Okay, this is of course you cannot avoid. Okay, when you digitalize your the door. Okay, you digitalize it. Okay, so next, after you look at the definition, so number 2 will go, actually, why do you need IoT? Okay, do you really need the door which is already controlled by your mobile phone earlier in the previous example that I've shown to you? Okay, actually, is there a business case for you to embrace IoT? Okay, so a lot of homes in the US have already things like Google Home. Some of them use Alexa. Okay, Do our houses we need IoT? Okay, do we need IoT in our streets? Do we need IoT in our cars? Okay, so this is all the questions that arises. Okay, because technology by itself is not useful if the person has no motivation to adopt it. Okay. Okay, so there are mainly four reasons why IoT is being used. Okay, so I got this diagram from HBR, Harvard Business Review magazine. So you can see there is four reasons why you want to adopt IoT in your business, in your life, and further on. Okay, so maybe some of you are using wearable already. Okay, so the first main reason is to monitor. Second is to control. Third one, you go higher ladder to optimize. Okay, especially in machines, maybe in your car. Okay, and finally, the highest level of Internet of Things is to have automation. Okay, automation. So you just leave the system, it will do everything for you. Okay, very less human intervention. Okay, so for monitoring, okay, I think most of us use it already. We have wearable devices, okay, where in this case, what happens is the sensors in this device or your products will read the values of, for example, here I have Medtronic digital blood glucose meter. So this is for people who are having diabetes. Okay. And second, you have the case of controlling things. Okay. So this is a very intelligent light bulb. Okay, you can just control your light bulb. This is a Philips light bulb, but you can have a lot of other variants or alternatives in from the internet. Okay, but this is a Philips light bulb. Okay, you can program it using your mobile phone. From your mobile app you can change the colors, you can set the ambience. Okay, and further on. Okay, so this Philips Hue bulb is actually an LED bulb with connectivity. Okay. Okay, so the second one is for you to optimize. Okay, typical examples are in factories. Okay, in manufacturing environment where you deal with a lot of machines. Okay, so the machines will need to produce typical or identical products. So there is issue of wear and tear. Okay, so the machines will need to be optimized, okay, in order to reduce defects. Okay, so usually people call this industrial IoT. Okay, so in the industry they will have the system which is more higher level, where it cannot only be controlled but it need to be optimized to produce a higher output. Okay, so you can see here there is issue of predictive diagnostic service and repair. Okay, actually if you are driving expensive cars like BMW, Mercedes or Tesla, in the car they already have sensors that will do built-in tests. Okay, they will test the car performance and they will notify the user if there is any errors or any problems. Okay, for in the car itself. Okay, actually this is already available in cars, expensive cars. Okay, and finally you have what you call autonomy. This is the highest level. Okay, anybody who uses a Samsung, sorry, not a Samsung. Okay, there's a lot of brands already. You have there's a picture here. This is actually I didn't remember the brand, but it is just a vacuum cleaner. Okay, automatic vacuum cleaner. So in the home, you have already such products. The vacuum cleaner, you can program it. It can vacuum your house, the floor and everything. Okay, so it can sense the environment. You can program it through mobile web. Okay, so in the fourth level, the highest level is what you call automation of operations. Okay, you have personalization and enhancement, and in some products you have the product have self-diagnosis and self-service. In the picture above here that I'm showing is a picture of what you call a farm robot. Okay, actually farming robots are already there. A lot of farming robots already there, but they are mainly used in big plantations, big farms. Okay, so this farm bot, okay, is an example of a small farming robot, okay, that you can buy and you can put in your house. Okay, I grow some of my own vegetables. Okay, so I have a small aquaponic system, sorry, a small hydroponic system in my house. So it's around 30 pots. So ada 30 cawan lah. So and I know that people say if you have 80 hydroponic pots, you don't need to buy vegetable anymore. Okay, you don't need to buy vegetable anymore. You can grow your own vegetables and without needing to buy any vegetables. So this is one example. The product is from US. It's quite popular already. So this is example of a system. You can say this is an IoT system. Okay. This robot you can buy and you can plant your own vegetable in your house. So everything automated, from injecting the seed, watering, weeding, okay, weeding, and it also can monitor, okay, the moisture of the soil. Okay, it can hold seed containers, and also you have camera. Okay, this camera can identify pests, diseases, food ripeness. Okay, there's a lot of algorithm in this farm board. Okay, this is the link, yeah. And actually, if you are familiar with this word open source, what do you mean open source? When you buy, you can reprogram it according to your needs. Okay, so let me show you this video. Okay, so because all of this is actually things that is already available in live. Okay, so let us watch this video. Yeah. Okay, so
open source CNC farming machine. Since then, we've manufactured and shipped over 1,000 kits to early adopters in more than 65 countries. Together with our community, we've refined this technology, and now we're ready to bring FarmBot to the masses. Say hello to FarmBot Express and Express XL, the first FarmBots designed and built for everyone. FarmBot Express grows food for you by taking care of your garden 24/7. It precisely sows seeds according to your desired layout and then waters each plant individually to take care of every plant perfectly. It can grow many crops at once and even accommodates large plants spreading over the front and back of the bed. Covering 4 times the area, Express XL is big enough to grow veggies for your whole family. Both of these new FarmBots come 95% pre-assembled in the box, so you can get set up in just 1 hour. Simply follow the online instructions to complete the assembly, mount FarmBot onto your raised bed, and plug it in. Robotic gardening has never been this easy. Using the FarmBot web app, you can monitor your garden and plan your growing season from anywhere. Our custom sequence editor now supports variables, empowering you with complete freedom and control over how your FarmBot works. Meanwhile, the drag and drop farm designer offers a game-like experience that is quick, intuitive, and fun to use. With built-in data for hundreds of the most common garden veggies, you'll be guided through designing an optimal layout in no time. What's more, with the Saved Gardens feature, you're just one click away from the next growing season and the next and the next. Using the onboard camera and advanced computer vision software, FarmBot can scan your garden full-time, find weeds as soon as they emerge, and then remove them within minutes of being detected. FarmBot Express is 1.2 meters wide and 3 meters in length, perfect for the outdoor classroom, research lab, or small backyard. At 2.4 meters wide and 6 meters in length, Express XL is large enough to make fresh food the centerpiece of your home or school. Best of all, both of these devices are by far our most affordable FarmBots ever. And as always, they're 100% open source. All of our documentation, 3D CAD models, software, and data is free for anyone to use for any purpose. That's because we're committed to building not only a technology that can help feed the world, but a community that is empowered to help out as well. So check out our website to learn more and place your pre-order for FarmBot Express and Express XL today. Thank you.
Okay, so even dia pun kata ya, even he mentioned that it's like a game. If you played Farmville ke kan, this is actually a real thing, okay? But it's now a game lah, a game. You can put your plants that you want to plant, okay? A real plants, okay? So this is the final business case, which is called automation, okay? So we have the 4 cases, which is autonomous. Okay, actually, in the future, like self-driving cars, they are actually going to the 4th level, okay, of the business case. Okay. So what is the components of IoT? Okay, so in general, now I want to go into the how. Okay, so in the IoT system, okay, you have few subsystems, but mainly you can dissect the system into 3. Okay, so the first one is the things. Okay, so this is how people architect the IoT. Okay, so you have what called things here, or the nodes, the end, okay, in the end user device, okay, or end user nodes at the site. Okay, so you have all the small processors, sensors, and software. Okay, so this includes things like your things like this processor. Okay, I have this. Okay, this is a processor like Arduino. It's called ESP32. So it's already built in Wi-Fi and Bluetooth inside. So you have already communication. So you can program this, and this will become a node. Okay. So generally the things, the device or the computing and communication nodes, okay, that you have here are what you call, there are two problems here. First is it is power constraint. Okay, I'm going to give you an example of your mobile phone, right? For example, your mobile phone is like, is an example of end user device. Okay, so the end user device, if you don't charge it, you will, the battery will not last for 1 day. Okay, because of the heavy usage. Okay, so similar to all this IoT device or end user device. Okay, so you need to make sure they are power, they have enough power. Okay, so that is the first limitation, what you call power constraint. The second limitation is actually memory constraint. Okay, all these devices, they have a small, very small memory. Okay, usually in the megabyte. Okay, for example, in your handphone, nowadays 16 gig is not enough, right? Okay, so you need 32 gig phone, or some people need 64, some people need 128 gig. So this is the limitation of end user device. First is power constraint, second is memory constraint. Okay, so but however, the most problematic is actually now power constraint. Okay, in terms of memory constraint, the industry already solved the problem where you can have large memory in small chips. Okay, so power constraint is always the problem in the things. And next is communication infrastructure. You have a lot of wired or wireless connection networks that you can connect to the internet. Finally, you have your internet infrastructure. So in your internet infrastructure, you have all the database repository and also the business and software applications, where this is basically the value of the Internet of Things. Okay, if you just have the things, the devices, the nodes, and the communication infrastructure without your application, without the analytical applications, it is actually not worth it. Doesn't mean anything. Okay, because data, just with data without analytics, you don't create new insights or new knowledge. Okay, next, I want to go to a very what do you call, complex diagram. Okay, this is the common, like big picture. Yeah, you have generated 3 subsystems, but if you go to the higher complexity, okay, architecture, okay, this is what it looks like. Okay, I got this from IoT Analytics. It's a very good diagram for you to understand everything, okay, on IoT technology architecture. So as I mentioned earlier, you have your hardware earlier, the things, okay, your sensors are all here. You have your sensors here, okay, you have also the communication hardware here. Okay, you have your sensors here, you have communication hardware here. Okay, another thing that people sometimes miss is like you have actuators. Okay, so examples, you have sensors, and then you usually need also actuators. Okay, actuators are things that give output. Okay, meanwhile sensors are usually receiving data inputs. Okay, so you have things like your processor also. Okay, so example, this hardware earlier. Okay, so there's a processor inside, there is a communication hardware inside. Okay, there is also LCD here already, so you can do a lot of things with this board already. Okay, so this is what you call development boards. Okay, this one, development boards. So all this processor, actuator, communication hardware, and sensors are already inside here. Okay, and so what you need to do is finally, okay, either you want to have an OS inside the system or not, and then next is for you to input the software, okay, the programming part. So this is actually your node, your hardware level. Okay, just want to show you one example of another device. Okay, this is a wearable device. Okay, so they have sensors here. So you can actually miniaturize this product to become something like this. Okay, so this is a wearable device already. Okay, so we have LCD screens there. Okay, it's called Hexiware. Okay, so all of this IoT system must communicate to the internet. Okay, so here you have all your communication. Okay, from the one that you are familiar with. Okay, if you are in Spectrum and in technology department, you know all of this technology needs your spectrum. Okay, so you have long range, high bandwidth. Okay, things like 4G, 5G. Okay, here is long range, low bandwidth, short range, high bandwidth. Okay, depends on your use. Okay, you will decide which one that you're going to use. Okay, so you can see if you need to transmit images, you need to use a higher bandwidth systems. Okay, higher bandwidth communication system. Okay, so and then you go to your network protocols, and next is your session protocols. Okay, so if you're familiar with networking, the most common IoT session protocol is called MQTT. Okay, and some people use HTTP also. Okay, so MQTT is for low data rate data. Okay, just for like normal sensor data. So going up to this higher level, you have what you call the middleware. Okay, the database, this analytics. Okay, so you have if you have machine learning here, you have processing. It will be done in this level. Okay, you can see also you need things what call network or device management. Okay, so the issue with IoT is if you want to have for example a building with an IoT system, you can imagine that how many nodes you have. Okay, for example, you have these nodes. Okay, so maybe you have 1,000 nodes, 1,000 IoT nodes, or 1,000 IoT device. So how you want to manage this device? So that's the complexity of actually the IoT comes. Okay, and finally that's why you have the device management. Yeah, okay, when your device is a lot. Okay, and if your device is a lot, your data is also a lot, so you need to process it. You need to have database, you need to have dashboard, you need to have everything. Okay, okay, so you can see see monitoring, switching, and all of these things. Yeah, so you need to have servers. Okay, the server, whether you want to use a cloud, a Google Cloud, Amazon Cloud. So people are now using all these clouds. Okay, Google, Amazon. Okay, so if you need to have extra layer of privacy, maybe you can't use these clouds. So you need to make your own local cloud. Okay, or your local server. Okay, and finally, this is the user interface. Okay, so you have the user interface facing of your IoT system. Okay, so you have all this business case. Either you're using it for your personal use or for business use. Okay, all right. So one more important thing is to digitize your data. Okay, for example, you have your wearable data, your blood pressure, your steps, number of steps every day. Do you really want your data to be shared? Okay, some people, they don't care. They don't have issues of sharing their personal data. But however, there's a lot of issue when you start to have all these devices. Okay, who can access your data? Okay, one simple example, if you have what you call smart metering, yeah, smart metering. TNB is already deploying smart metering in some houses. So if people want to know are you at home or not, they will only need to look at your electricity usage data. So it's quite dangerous. And in some case study, they have shown that all these IoT device data can be used in court. Okay, for example, if you want to have an alibi, okay, you can show that you are actually using electricity at that time in that house. So maybe you can prove that you are not uh, guilty of that crime somewhere outside of your house. So all of this, yeah. So security is actually a big issue in IoT, similar to the current network issues. Okay, so this is a very good diagram to understand the complexity of your IoT system. Okay, because earlier the diagram that I showed you earlier, it was a very simple diagram, yeah. A three. Okay, sorry. It's a three. Okay, this one, yeah. It's a three subsystem. But however, if you see the next diagram, okay, if you want to understand more, you can use this diagram. Okay, it's from IoT Analytics website. Okay, so where it is being used, okay, there's a lot of IoT being used already in your wearables, and who are using it, people, things, okay, when they're using it, okay. So this is all the questions. So I just want to give you like big examples of where it is being used in terms of like business. Okay, so you have already the TNB smart metering. I think MCMC knows this because when they deploy, they need to get the approval. So I think they implemented in Malacca for their I think it was a prototype testing. Okay, they already have. Okay, you can see there's three type of meters. One is using RF, one is using power line, and one is using GPRS, which is your 2.5G cellular system. So you can see in the TNB website, there are some good testimonials that if you know, you can download the TNB app, and then from your TNB app, you can you can see your utilization. So you have things also in Sunway where you have here number plate recognition. Okay, so you can pay, you can park just using the app, and it will recognize your number plate. Okay, next is you have this system being deployed by Xperanti. It's a Malaysian company using Sigfox in the this is a plantation for pineapples. Okay, next one you have a system deployed by Mimos. I think this is the case where they deployed for palm oil plantation. Okay, and you have also some local products wearable Korakit. Okay, it's by Favorite. Okay, a local company. It is a wearable for pilgrims. Okay, so when you deploy the IoT system, okay, you will look at okay, for engineers or for system managers, they will look from the small aspect, okay, which is the product itself, number one, making it more smart, okay, and then connecting it, and then hooking it into a system, and finally having a very complicated system of systems. Okay, here you have example of farm management system. So there's a lot of issue when you have a system of systems. Okay, so this is how you can scale your IoT system. Okay, so if you just have one device, it is very easy to manage. Okay, for example, earlier you have a smart building. If you, for example, you have 1,000 devices like this, how are you going to manage your system? So there's a lot of issues in IoT, okay, and I can list 1 to 6 issues, okay. um, First is, with all these nodes, you will have a what you call data deluge. Okay, so the issue here is, with all this data, raw data, which one is more important? Do you want the raw data or you want the insight? Okay, so a lot of data is meaningless unless you translate to analytics. The second issue is the privacy and security. Okay, so a lot of IoT nodes can be hacked, and these nodes can send false data. Okay, so you have issue of the data integrity, and then some people can hack into the communication. Okay, it's very similar to communication network issues. Okay, people can there is a case where uh, an IoT company is making a a bed. Okay, a bed. So like when you sleep, they will send the data to the cloud, your sleeping pattern and everything. So when he monitored, when this lady monitored the traffic of data going outside, uh, she noticed that this company was harvesting his data of his sleeping pattern and everything. So without her noticing that all his sleeping data was shared was shared in the cloud. Okay, so that's the issue of privacy and security. And as I mentioned earlier, there's issue of power constraint. Okay, so you have issues of most of the IoT device are battery powered, okay, and they are not wired. The fourth issues is massive IoT means you have a lot of nodes. So how are you going to manage the thousands of nodes? And another issue is, if the product is heterogeneous. Okay, the problem with IoT is maybe you're going to use IoT products from maybe 10 manufacturers or 10 type of brands. Okay, so how are you going to manage all this? uh, fifth the fifth issue is you have software updates. Example, in your handphone, you can have automatic updates because the phone is quite advanced level computing. So how do you update things like this? Okay, like your devices, all this, the small nodes. Okay, if you want to tweak something, you want to get new data, so how you going to do the software updates? And finally is, can a civilian program a device? Okay, for example, if I have this device, one day I want to uh, measure the temperature of my kitchen. Okay, the next day maybe I want it to sense the humidity of the kitchen. So can I reprogram this? Okay, so these are all the issues of when you have a lot of the IoT device being scaled up. Okay, so there's a few evolution of IoT to address the 6 issues earlier that I mentioned to you. Yeah. Okay, so um In this diagram, the right side, okay, you can see how computing evolved from mobile, ubiquitous, ambient, and to Internet of Things. So you can see here the data as the nodes increase, you have enormous data amount. So with enormous data amounts, you need AI. Okay, AI is called artificial intelligence, of course. Okay, you can see that a lot of the data need to be filtered. Okay, you just want insights. So how systems are evolving right now is like the processing of data is generally sent to the cloud. So you can see all the analytics and knowledge are in the cloud. Okay, one typical example is, if you want to use your Siri or your Google, right? If you don't have an internet connection, you cannot ask Siri, for example, any question, or you cannot ask Google to answer your question. So it shows that all the computing capability or analytics is being done in the cloud, in Google, okay, or in the Apple server. Okay, so people are moving to what you call edge computing. So here all the data doesn't need to be sent to the cloud. Okay, so this is your cloud. So all the processing can be done here in the gateway. Okay, so this is what you call edge centric. So in computing, there is always a shift between cloud and edge. Okay, so you solve the problem of number one and number two, okay, which is data deluge. Okay, and then next is you solve the issue of privacy. How do you solve the issue of privacy? Now you don't need to transmit raw data. Okay, you don't need to share raw data. What the data that going to be transmitted to your cloud is only the data that is finalized or the results only. Okay, so a lot of your personal data can be safe. Okay, so basically you also don't need to have a very high bandwidth. Okay, you don't need to have a very high speed or high data rate. You only send the results. Okay, because the data is meaningless. Okay, without the results. Okay, and there's also a third architecture which is called fog centric. Okay, which is computing is everywhere, in the edge or in your gateway. Okay, the second issue is security. Yeah, so a lot of devices are now being certified in terms of the firmware. So you have all this issue, for example, in the US, in the UK, they already banned Huawei. Okay, this is because the firmware. Okay, firmware is very dangerous if they put something, because you can't. They put some code in the assembly form, in the binary form, that you cannot detect. Okay, so a lot of these device, the IoT device, need to be certified. Okay, in the firmware. Next, you have authentication. Okay, so this is already being done in IoT. In some applications, they are already putting encryption, and also in some advanced processor, they put blockchain. Okay, so you have other examples of like contract between devices. Okay, because when you have IoT system, you have machine to machine. So there is all this handshake verification. Okay, and if your IoT system have payments, okay, and also traceability of data. So this is all the evolution, okay, of IoT, where you want to make all these things more secure, yeah, and also more intelligent, smarter, yeah. Okay, so let us see one example on the embedded machine learning. Yeah. Okay, so this is a board called Arduino Nano. Okay, so you have this small board. Okay, so it is actually a quarter of your credit card. Okay, so what it can do is, okay, it can, okay, I will play this one. Okay. Okay, you can see that it is basically identifying the fruits. Okay, and the identification is being done by using color input. Yeah. Okay, so it has a color sensor here. Okay, so you can sense the color, and this small device, they put already machine learning. If you are familiar with this, called an algorithm called TensorFlow machine learning algorithm. Okay, so from the colors, it's just like a human intelligence. Okay, so you can detect whether this is an apple, banana, or an orange. Okay, so it's already here. Okay, all this technology. Last time, yeah, this chip, yeah, this small chip cannot do machine learning. Okay, because it is power constraint and memory constraint. But they already reduce the complexity of the machine learning algorithms to be input to a microcontroller. Okay, second example is okay, you have this device called Jetson Nano. Okay, so this Jetson Nano is a graphic card basically. I think everybody knows what NVIDIA is. Okay, so in NVIDIA you have graphic cards. They make graphic cards, and in the machine learning community, machine learning programmers are using it to program hardware for machine learning. Okay, so it is generally used for image classification, object detection, segmentation, and speech processing. Okay, so generally, if you want to make your car more intelligent, you just put sensors, okay, right and left. So it will detect the black line in the middle. So this is how you can make your robot or your car, yeah, move in a straight black line. Okay, however, now you have the latest technology where you can impart the machine learning inside this board. Okay, and with the image processing in real time, it can detect whether going in front will be blocked or not blocked. Okay, so just want to show you this example. Okay, so and this board is only $99, which is around 400. So actually you can make your own smart car or something like that, your driverless car. Okay, so this is the code. All the code are there. You just need to download it and in the board with assemble it into a robot. Okay, and
control way, we could open up a new tab there and go down to here and select a terminal. And in the terminal, we could do a sudo and a shutdown.
So
and now, enter the
So this is the board. So this is collision avoidance.
right. We're now going to another dam where the robot's going to control itself using vision recognition. Or more specifically, what it's going to try to do is avoid collisions by taking the feed from its camera, constantly analyzing what it can see in that feed, and working out whether its path ahead is either unblocked, in which case it can move forward, or blocked, in which case it's going to turn. So to do this, there's quite a lot of code to execute. I'll execute all of this code. And you can now see we've got a image from the robot. We can see whether it thinks things are blocked or unblocked. So we'll just continue with the rest of the code.
Okay, so
it comes back again.
I will just show.
Got caught in a loop there. As you can go any further, going round. Oh, this is interesting. It's catching itself a bit, isn't it? Maybe I should move it to a more open area. Let's move it back over there. There we are. We can do a longer run now. I'll bring up on the screen what it's seeing, so you can see that. You can see here. Let's go down to that. I forgot to do it. I was so interested about where's what it's seeing. There's what it's seeing. It's blocked or unblocked. Let's put that on the screen, so you can see when it thinks it's blocked, it will turn. When it isn't blocked, like now, it won't turn. Put my foot in, it'll turn. There we are. And
okay, so this is to illustrate to you that now you can have this device and you can make a robot that can process in real time without sensor. So it is basically using image like your eye. Okay, it's similar like your eye. You like when you are driving, you know that okay, there's an obstruction in front of you and you need to avoid, okay, the collision. So so this yeah, it's a very decent price board, $99. So you can already program it, okay, to put a lot of things. Okay, so this is what you call the making your IoT system smarter and more smarter. Okay, so you put a lot of AI inside. Okay, the next issue with IoT was actually power. Okay, so in terms of power, when you develop your IoT device, there's a lot of move for people to harvest, or what you call energy scavenging. Okay, so you can basically harvest energy from the environment, the heat, the vibration, solar, RF, and also there's a latest big breakthrough. Last July, there was an article. They have shown that you can power your wearable or any device, small power device, using your sweat. Okay, so this is actually a big issue if you have a lot of nodes. Okay, if you have a lot of nodes, are you going to replace your battery every 1 year? For example, you have 1,000 nodes, okay, and the 1,000 nodes have in different location. So how are you going to address all this issue? So power constraint is actually what you call the holy grail of all these small IoT nodes. Okay, so if you can have the breakthrough, okay, of harvesting all the energy without, and then storing it in a local battery. So this is actually the main issue of all these devices. Okay, and finally you have an issue of software updates and ease of programming. So when you want to have your devices to be updated, okay, for example, in a case of your handphone, okay, how do you manage it? Okay, is the devices that you send or you use is intelligent enough, okay, is complex enough to receive new software, new updates. Okay, so people are already working on such systems, okay, where a lot of all these nodes can be updated. Okay, can be updated. The application can be renewed. Okay, and another issue is can anybody program it? Okay, can anybody change it? So we are actually going to move into this area where anybody can program your system. Okay, so maybe I just want to give you an example of this set. Okay, this is actually okay. The set, if you can't see, the set here is actually a kit. Okay, I think it's around 200 ringgit. This kit is for kids. Okay, they can make their own IoT system. Okay, how they program it? They program this board called microbit. Okay, this is half credit card size. Okay, and they can connect it to the internet, a cloud called ThingsPeak. And you have a lot of sensors. For example, one of the sensor is a temperature sensor here. Okay, this is one of the sensor, yeah, temperature. And then in the cloud, you can see the data of your temperature by using the setup. Okay, and how do you program it? You use a Scratch-based programming, something like this. Okay, so this shows that in the future, if you have an IoT product or IoT device, if it's open source, you can program it simply like this. Okay, and if you are familiar, if you have kids, you know that your kids are actually doing programming in standard 5 and standard 6 using Scratch. This is Scratch-based programming, so you don't need the command line programming. Okay, the like in C. Okay, so this higher, what you call higher level language programming will liberalize the users. Okay, so users, you can change your device function anytime, anywhere in the future. Okay, so I think with that, I would like to end my presentation on the IoT. So I think I dragged to more than 1 hour. Okay, sorry. Yeah. Okay. I thought I can finish it in half an hour. Okay. Okay. I can. If there is any question and answer, I can try to answer. Because this is just a sharing session. There's a lot of actually development in this IoT area. Okay. That even I myself is learning day by day. Okay. So I can give back the session to Puan Sharifah.
Yeah, we open to questions. But if you don't have any question now, you can email to me. I can forward that to Dr. Aziza. Siapa?
Assalamualaikum.
Yes, Katie.
Yeah,
Hello.
okay.
Doctor, I'm
Yeah,
Khadijah,
yeah.
Katie,
Katie, yeah.
from RMD department. So
Okay.
as you mentioned of the IoT is data protection and
Sorry, Katie, hilang.
Can't hear
Hilang.
you.
Yeah, miss you. Katie, are you okay?
okay, dengar?
Dengar.
Okay. Nak ulang balik ke? Ke macam mana?
Boleh ulang.
Ulang balik Okay. As you mentioned of the challenge for IoT is
Yes.
data protection and privacy security.
Yes,
Okay.
yes.
So what is your opinion or suggestion to us as a regulator need to look in terms of data protection and security challenge? So in your opinion lah, apa yang kita nak fokuskan?
Okay, my opinion, I think there's two things lah. First is education. When you start to use all these device kan, users need to be aware there is some consent issue. Sebab all the small print kan, all the small print ni sometimes we don't realise kan. Uh, um, whether the companies are actually harvesting your data. Okay, so that's the first one lah. That's the first one. So when people agree kan, dia buat the small tick kan, they agree the small apa yang small apa contract tu kan, kita just tick I accept tu kan. So people really need to understand lah that their data will be in some sense harvested. Okay, kalau macam you guna Tesco card kan,
Okay.
you agree kan sebenarnya they will give promotion to you kan semua kan.
Kita akan take agreement macam kita tanda kan. Kita
Tapi
setuju.
yang tu you agree tau, you redha tau. Tapi in terms of like sometimes this IoT device kan, the users kan whether they want this data to be harvested or not. That's the issue. So I think when people start to use, they need to understand this thing lah, right?
So maksudnya dia pun kena redha lah kalau kita dah implement tu means.
Tapi first is the awareness lah, or the user awareness. But it's actually very difficult kalau you tak ada good legislation. I think macam EU kan, EU legislation is very strong. They have a very proper legislation macam even for Google kan, by 1 month you have the power to be forgotten. Macam you boleh erase semua dia punya cache data kan. So I think for regulators you need to really look into this area. Cuma in Malaysia Data Protection Act is being governed by JPD kan, Jabatan Perlindungan Data. Something familiar, so I'm not sure how MCMC comes into it. Okay, the second thing is regulation on data. In terms of companies lah, I don't think we can do anything much about these companies. When you start to use their product, they actually harvest your data. Facebook, Google, saya pernah tengok macam case people are using Google Home kan dengan Alexa kan. Actually Google kalau dah you start all these products kan, they know lah what you are doing in your house. So in that sense yang tu kita macam tak ada power lah. We don't have any more power because when you start to use the device, you are actually basically agreeing that your data will be stored in their cloud. You can't avoid that. In US there's a lot of what do you call community action. Diorang dah start lawan Google, lawan Amazon tau. Sebab the public are very afraid that these companies are now more powerful than government. So dia memang ada civilian punya, dia ada community punya movement tau.
Macam right, dia untuk protect lah community tu, dia set up.
Ya, tapi dia cuma dia bukannya government punya movement lah. Dia movement from community sebab dia perasan Google, Amazon ni dah become too powerful lah. Jadi dia akan monopoli. Dia boleh tahu apa yang you buat. So saya pun ada banyak baca artikel on this lah. Tapi in the end it's the government lah whether you want to regulate it. How powerful you want to regulate lah. Sebab unless you become like China lah. China tak ada Facebook kan. So Google pun exit from China kan. So it's something like that. Okay. That is my opinion on all these issues of data and privacy. Because once all these devices enter your home, you need to really be aware. The users need to be really aware. Okay. Okay. Thank you, Katie, for the question.
Okay, thanks, Doctor, for your explanation.
Yeah.
Okay, I think we have to end the session now because it's already past 1 hour. Any question you can pass it to me, and inshallah I will forward that to Dr. Azizul. Okay,
Thank
with
you.
that, thank you, Doctor. Inshallah, we'll keep in touch. We hope
Yeah.
to see you again.
Yeah. Thank you for giving me the opportunity. Okay.
Yes, and for the participants, we will send the e-evaluation form. Hopefully, we can get a response from you. We appreciate that. With that, we end now. Thank you, Doctor. Thank you all.
Okay, thanks. Okay, terima kasih Puan Sharifah. Thank you
Okay, ya,
all.
terima kasih. Insya Allah.
Assalamualaikum.
Assalamualaikum.